So, when we first started our conversation about circles a little while back, I asked you, how are ellipses and circles similar? And we didn't have a ton of information at that time, so we were probably not 100% sure. We got a little bit more information now. And so now I'm going to go the other way and ask you, when are ellipses actually circles? What does it take for them to look like that? So, when we talk about ellipses, or what an I'm going to go back to make it singular. When I talk about what an ellipse is, we're talking about the set of all points whose distances from two fixed points and we'll define those as foci, which is more than one focus. So those distances have a constant sum. So for a circle, it's 1 point, one fixed distance. Now we have 2 points, so it means we have 2 distances, but they just have the same sum every time. So if we draw an ellipse, oh, I didn't really want it purple. So I'm gonna undo that. If I draw an ellipse, that looks better. That's sweet how it gives me those dash lines. I wish I could keep them on there permanently, but we'll go with it. Anyway, so here's our ellipse. It's a good looking ellipse. We did our best. And I want to label some important pieces on this ellipse so that we can kind of talk through it together. So you're going to hear kind of some interesting vocab words, but it's all going to make sense. So let's start with the center, which appears to be right about here. Okay, there's our center. And from our center, we're going to put some extra points, and I'm just going to call them, I'm going to put one of them here, which is our focus. And I'm going to put another one the other same distance away from the center, and I'm going to call it our focus. Okay? I made them green to match up above. Now, we have some other key pieces on here where if I go all the way out to the edge, I end up with my vertices. Okay? They're on the ends. And the vertices have a length of A away from the center. And then they are part of, if I go all the way across, that's our major axis. Okay. Now, if I go the short way, those are our co-vertices. And they are a distance of B away from the center along the minor axis. So we've got a lot of these key ideas laid out, and they're all going to kind of fit together, and we'll see how they're all connected, and it'll be awesome. So here we go. We are going to talk through 2 equations for these ellipses, and the first one's going to be kind of our horizontal ellipses. So I'm just going to go x and then I'm going to put A underneath x for this first one and B underneath y. And then for the second one, I'm going to do the same thing, but I'm going to switch it. I'm going to put B under x and A under y. In both cases, we set it equal to 1. Okay, so here's our two sort of equations that we are digging into. Now I'll use purple. Now I'll go yellow. Okay, and you'll notice they're super similar. You'll notice they use a lot of the same letters other things have used. A and B are going to play a pretty key role, and I'll show you what I mean here in a second. So first of all, let's just kind of sketch this out. So this first equation corresponds to more of a horizontal ellipse, and then the second one is a vertical ellipse. And everything we do for these ellipses, we're going to say that A is bigger than B. In other words, A is always the bigger number, and if A is bigger and it's under Y, that's how we get our vertical one, and if it's bigger under X, that's how we get our horizontal. So I'm going to lay out some key ideas. I'm going to lay out 5 of them, and then we're going to pause, then we're going to lay out a couple more. So I want to first talk about the major axis, the semi-major axis, and some of these words maybe you didn't see in your Desmos, but I think we'll get them all kind of figured out. We can talk about a minor axis. We can talk about a semi-minor axis. We can talk about, shoot. If you've been writing stuff, wonderful. I'm going to do this real quick. I'm going to get and use technology my favorite. I forgot that I want to open talking just about the center real quick, so I'm going to sneak center in there. Sweet. Want to talk about vertices. They are important. And I want to talk about covertices. And then we'll pause, and then we'll talk about those foci that were so important in our original definition. So our center, because I'm very boring and because math people are boring, the center is still at HK. Okay. The major axis for this particular one is along X, and it equals 2A. For this one, it's along Y, but it still equals 2A. It's always, the major one is always double the bigger number, right? That's kind of what hopefully you were aware of. So our semi-major axis, semi means half, so that's A. Our minor axis equals 2B, and it's just kind of the opposite. So then our semi-minor axis is just B. A and B are really the numbers we care about, but there are going to be times where I want to know what the length of the major axis is, or that it might be helpful to know. Okay. So let's talk about our vertices. Our vertices here are going to be on either side of our center in terms of X. And then our covertices are going to be on either side of our center, moving vertically. Now, for a vertical ellipse, for one with its major axis going in the Y direction, we have the same thing, we just sort of flip it. Okay, so there's tons of information there, and I think, yes, it's very formal, but that's more of like taking what you did in Desmos and kind of making it a little bit more, I guess formalizing it is to use that word again. But I also know that as you see it, it clicks. So even though this looks a little heavy with a lot of letters, as you see it, it's going to click. But now let's talk about the focus and those foci. They are a distance of C away from everything. And so we need to have a formula to figure out C. Well, according to how all this works, we are going to use the Pythagorean theorem, just a little bit different. C squared equals A squared minus B squared. So if I know what my focus is, Or if I know what A and B are, I can find out what C is. Because my foci, whoops, undo. My foci live C away from the center. And they live on the major axis. So if I'm talking about a horizontal ellipse, like this first example, I'm going to add and subtract C from that center coordinate. Same thing here, except for it just happens to K. Now, before we totally wrap up ellipses, we're going to start to talk about this word eccentricity, right? And it's just about how squished is your ellipse, right? Eccentric means odd. Eccentricity in terms of an ellipse just means, hey, how squished did we squish it? So it's going to be C over A. And for an ellipse, our eccentricity should be less than 1. C should be smaller than A, right? Because the foci, if I go back up to the top, the foci are closer to the center than the vertices, so their distance of C is less than the distance of A. So if I wanted to label it in terms of this picture, that would be our C. A lot of information on ellipses, a lot of cool stuff happening. Let me know what questions you have. You got this.